Hello, class, and welcome to part 3 of Topographic Maps. In this section, we will be going over contour lines and possible elevations. Now, similar to the map that we saw in part 1, we see a map below, and this is a topographical map. The lines drawn are similar to the lines you drew in the previous section that show lines of equal elevation. So by definition, a topographic map or a contour map is a map that shows changes in elevation of the Earth's surface. Here's a simple drawing. A contour line is an isoline used on a topographic map to connect locations that have the same elevation. Now you'll see the lines on the bottom of this page where we have a dark line here. You see the elevation here is 50. Now it's going to be 50 meters because our scale on the bottom here is in kilometers. And then up top here we have 100. So that would be 100 meters. And then we have our other contour lines. So it would go from 50 to 100. So we're gaining elevation as we move in this direction between D and B. Now we're going to consider how much each one of these is worth. So we'll go over how to do this a little bit later on. But if this is going up by tens, if our contour interval is 10, this would be 50. Next line would be 60. C would be 70, 80, 90, 100. So how is elevation shown on a map? We see two different types here. This would be a three-dimensional perspective on the top. A three-dimensional land perspective. So if we were looking at a mountain, this is what we might see, the height, length, and depth of the mountain. Those lines won't be there. When we look at a map, that three-dimensional landform is shown the same way as we see below it, which is a two-dimensional topographic map, where we just get the length and the width. We don't really see the height, but the height is labeled with the contour lines. Now, all elevations are measured from above sea level, which has a value of 0. So 0 elevation, 0 feet above sea level. So, for example, when we look at the images above, it all starts at 0. So that must be the sea around this, so this figure could be considered an island. Now, the contour line that borders the ocean always has an elevation of 0 feet or meters, as I was saying before. Now, a lake or a pond, is not the sea, and we can find lakes and ponds located in the high mountains. So we wouldn't consider that to be 0 when we're talking about lakes or ponds. So the landform must be in the ocean, as I was pointing out before, because the exterior contour line is 0. Contour lines that are in the shape of circles indicate a hill or a mountain peak. So in our three-dimensional landform perspective, we see that there's a gain in elevation to a single point, or you see here there's a saddle with two little hilltops. When we look at the two-dimensional topographic thing, we see how it comes to a circle, where at sea level it's at 0, 10 is a circle, 20 is a circle, 30 is a circle. Then the highest elevation of the contour lines is 40. Index lines. Now, the index lines are the darker lines that we see labeled on the map. ISO lines that have their value labeled on them. And you see in parentheses that it's frequently darker than the other ISO lines. This is important, that we don't label every single line on a map with a value. Otherwise, our map would be congested with numbers. So if we just put in the index lines, and we understand what the contour interval is, we can find out what the values above and below them are. So we see our index line down there, that's a 50. And as I pointed out before, up top, we have an 100. And also we have 100 on the right-hand side here by Crow Mountain. Now, I talked about the contour interval before. Now, this is the difference in values between the ISO lines that are next to each other. Sometimes on a map, you are provided with the contour interval, but sometimes you need to derive it on your own. This is a subtraction with a division problem. So the contour interval on a map will never change. It's a constant as we look at the map. Now, not all maps have the same contour interval. So in order to find the contour interval, you're going to follow the following procedure. The first thing you're going to do is find the difference in value between the index lines. And you're going to subtract the smaller from the larger number. So here we see a lake, and we know that lakes aren't 0. But we do have two index lines. We have 80 and 40 meters. Okay, we see that it says elevation in meters on the bottom right-hand side of the picture. Next, we're going to divide that difference that we calculated in 1 between the index lines by the number of spaces between the contour lines that are between the contour lines. So between 40 and 80, we see we have 1 between 40 and this line here, and then we have another. So we have 2 spaces. So when we take 80 minus 40, we have the value of 40. Now we're going to take that 40 meters and divide it by the number of spaces. So 40 meters divided by 2 is going to be a 20 meters per interval. So that means that our middle line in between the 40 and 80 would be 40 plus 20, which makes it 60. Or if we were to go below the 80, it would be 80 minus 20, which would make the middle line 60 as well. Okay, so let's do our checkpoint. What is the contour interval for the map above? What you should have done is calculated the difference between the interval of 150. Okay, so we have 150. We're going to subtract 100 from 50, and we're going to see that it's a 50-meter difference. With that, we know there are 5 spaces. We have 1, 2, 3, 4, 5 spaces between the 50 and 100. We take the 50 meters, divide it by 5 spaces. That means that each line is going to be an increase or decrease of 10 meters above or below. Okay, so our contour interval is 10 meters. Okay. Now determine the elevation of the following points using the map above. C. With the contour interval of 10 meters, we're going up from 50, so the next line would be 60, and C would be 70. Now do G. If G is here on the pond, okay, we see here that this dark index line is 50, so H must be 40, and G would be 30. Now for H. Now I already told you what H was, hopefully you were paying attention. If the dark line here is 50, we're going down 1, we're decreasing our elevation by 10 meters, so H would be 40. Now for I. I is right here, and this line continues all the way over here, so we could either go from the 100 or from the dark line of 50 below. So if this is 50, 60, 70, I would be 70 meters. Okay, for this problem, the contour map to the right shows a small part of the coast of Maine. Now, off the coast of Maine, there are a lot of islands. And we also see that this is located in the Atlantic Ocean. Which island is less than 20 feet high? And how do you know? Now, when we look at this map, okay, we see the 4 islands of A, B, C, and D. We want to know which one's less than 20. Now, if it's on the ocean, that means that the exterior contour line for each one of these islands is going to be 0. Okay. Now, as we come up from each one of them, according to our map here, says an interval of 20 feet. Okay. The only one who doesn't have any lines above sea level, okay, is C. Okay, so your answer should have been C because there's only one contour line surrounding the ocean. Okay, as I said before, that is 0 feet. B. Which island has 2 hilltops, and how do you know? You should have picked A. Island A because there are 2 separate circles indicating 2 different peaks. So that means that it raises elevation in 2 different locations on that island. C. How far in miles is it from point P to point Q? Now, this would be too difficult to do on your computer, so I'm going to do it with you. Now, I can measure this in straight line or curved line distance. Let's say if I was walking the beach, okay, I would walk along the in cove there of P to Q. Okay, but we're going to do straight line distance. So I'm going to put my piece of scrap paper between P and Q, mark P, mark Q, and I'm going to move my paper down to the scale. And I see it's 1. Now I have to make sure I have the right units. And in the bottom of the scale, you see it says miles. So it's a 1 mile distance from P to Q. Now you can only imagine that it would be a longer walk to walk along that shoreline to get from P to Q using the curved line method. How can you determine possible elevations between the contour lines? So now we have the contour lines drawn and we want to figure out a point that's not on the line. Possible elevations are locations in between contour lines that can be estimated. So we're not looking for the most precise answer. We're looking for an acceptable answer, okay, between the contour lines. Okay, it's just an estimate. The elevations can be any value that are between the contour lines but cannot be equal to the contour line values. Otherwise, they would be on the line. So we're going to have a couple examples here. So what are the possible elevations in feet of point X on the topographic map? Now you see the contour lines to the outside of X are both labeled with 40 and 20. Now the value can't be 20 and the value can't be 40. Okay, it could be one value higher than 20 and one value lower than 40. So what we see for a range would be any value from 21 to 39 feet. Okay, 21 because it's not on the 20 line, and 39 because it's not quite 40. So any value between 21 and 39 feet.